Okay, so this is the solution for the lab. I know only about a third of the class handed that one in, so this is the solution you can check your work with. What we're looking at here is we have angles A, B, C, D. And as always, you want to add them up. 59, 23, 0, 0, 55, 19, 24, 143, 15, 02, and 101, 59, 10. When you add these up, you're going to get 359 degrees, 56 minutes, 36 seconds. Now it's a four-sided figure. N minus 2 times 180 should be 360, which means we're off by 0 degrees, 03 minutes, and 24 seconds. Divide that by 4 angles, and that would be equal to 0 degrees, 0 minutes, and 51 seconds per angle. We're less than 360, so we're going to add it. And that will give us new angles of 59 degrees, 23 minutes, 51 seconds, 55 degrees, 20 minutes, 15 seconds, 143 degrees, 15 minutes, and 53 seconds, and then 102 degrees, 0 minutes, 1 seconds. And we're going to add these all up, 360. Okay, so that was our first step. Once we have those, now we want to change these. So this angle becomes, I'm going to cross them out so I don't accidentally use the same one. Angle B, 55, 20, 15. Angle C, 143, 15, 53. And angle D, 102, 00, 01. All right, so those are the angles. We're given the first bearing of line CD. That means we start at point D, and we draw on the back bearing. So we're going to start at D, and we draw on the back bearing. CD is northwest. I'll put D over here. I have it in all quadrants. CD is northwest, so DC becomes southeast. Southeast. Say it while you write it. That is 53 degrees, 51 minutes, 15 seconds. I draw on my interior angle. The interior angle is measured from line CD to DA, and that tells you the direction we're going. It's always in the direction of the given bearing. That angle, let me just draw this in a different color. That's too thick. So undo that. There we go, that's a little bit better. That angle, that's my interior angle, that is 102, 0001. So to get the difference between those, I'm looking for DA. So DA will be the difference between 102, 0001 and 53, 51, 15. So 102, 0001 minus 53, 51, 15. And I get 48 degrees, 08 minutes, 46 seconds. Direction on that, southwest, southwest. Remember, your bearings must be less than 90. If you get a bearing, what you think is a bearing that's more than 90, either you're measuring the wrong angles or you're not figuring out what the unknown bearing angle is. My advice, figure out what quadrant it's in first. In this case, it's southwest. And then as you say it, put your pen on south and go to the west, or north to the west, or north to the east, whatever it may be. We want our azimuth. Azimuth is taken from north all the way around. So we can just add 180. 0, 0, 0, 0. And that gives me 228 degrees, 08 minutes, 46 seconds. That's my azimuth. Okay. And at any time during this video, please pause it or stop it if you need to, take some more notes in here, or backtrack if you have any questions. Next compass rose. Every point you draw, every point you have in a traverse, you need a compass rose for. So the next compass rose, we just did DA, so A goes in the middle. And we're drawing our back bearing. DA was southwest, so AD is northeast. Northeast, that is 48 degrees, 08 minutes, 46 seconds. Then I have internal angle A. From D, I measure my internal angle, or write that in, 59 degrees, 23 minutes, 51 seconds. And I'm looking for this southeast angle. That's my bearing. So to figure that out, well, I have, here's north, here's south. My azimuth would be, if I want my azimuth, that's north going clockwise to the point. So the azimuth and the bearing equals 180. So let's do it a little bit differently this time. Let's take 48, 08, 46, and we'll add 59, 23, 51. That gives me my azimuth. So let's see, that's going to be 48, 8, 46, plus 59, 23, 51. That gives me an azimuth of 107, 32, 37. If I subtract that from 180, that gives me a bearing of 72 degrees, 27 minutes, 23 seconds southeast. Okay. So we go on to our next compass rose. We just did, this was AB. Now we're going to do BC. So point B goes in the middle. I draw on my back bearing. Southeast becomes northwest. Northwest. That is 72 degrees, 27 minutes, 23 seconds. Then we have BC. BC has an internal angle of 55 degrees, 20 minutes, 15 seconds. And I'm looking for the bearing, which is a northwest. Northwest. I know it's this angle because it's the only angle that to get line BC, it starts at north and goes to the west. You're always drawing an arc to the line you're looking for. So we're subtracting one from the other. So 72, 27, 23 minus 55, 20, 15. Will be 17 degrees, 07 minutes, 08 seconds northwest. All right, make sure you put the 0708 in. My azimuth is taken from north, clockwise around, so I can subtract that from 360. .342, 52, 52. That's my azimuth. Okay. So that was just BC. Now I'm going to do CD. This is my last one, and it should really just be a check for what I had. So C goes in the middle. I draw on my back bearing. I had northwest, so CB becomes southeast. That angle, that's the back bearing, 17, 07, 08. I draw in my internal angle. My internal angle is 143 degrees. So that'll be CD. That is 143 degrees, and I'm using my adjusted angles, 15, 57. That's what I'm looking for, CD. It's a northwest bearing. So this one's a little bit trickier. What I have is I have this one angle that goes, if I sum these up, I have an angle starting here. I can go all the way around to here and then to here. So I have all of that red. That's my total angle. What I'm looking for is just the northwest part. So if I subtract out this part, that brings me all, that gives me just a piece of it, but I got to incorporate this 17. So basically what I'm going to do is I'm going to take the 17, bring it back to here. So that's 143 minus 17 brings me to here. Then I can subtract the 143 from 180 and get the northwest. So, or the other way of looking at this is I have 180 degrees plus the 17. I like that option a little bit better. So add 17 degrees, 07 minutes, 08 seconds. So 180 plus 17, 7, 8 is 197 degrees, 07 minutes, 08 seconds. We're then going to subtract 143 degrees, 15 minutes, 57 seconds. And that will leave me with a north 53 degree, 51, 15 west bearing for CD. My azimuth, starting north, go all the way around. I can just subtract that from 360. That would be 306, 08, 49. That's my azimuth. Okay. So now we figured out the azimuths and bearings. Hopefully that was pretty straightforward and you don't have any questions on it. If you do, as always, please email me. I'd be more than happy to talk with you about this stuff. But if you don't let me know you're having problems, I can't help you with it. Okay. So now I'm going to start my chart. I'm going to look at my chart where I'm going to figure out what my line is, the distance, what the bearing is, and then from that, I'll figure out my latitudes and my departures. So I'll do it in order. DA, AB, BC, CD. And you could do it really, honestly, in any order, as long as you just keep your numbers together. Here's my distances. And 366.40. While I'm here, I do need my perimeter. So I'm going to add these up. 2382.10. Okay, that's my perimeter. You will need that. You also need your bearings. So I'm going to, from my sheet above, I have my bearing is south, 48, 08, 46 west. South 72 degrees, 27, 23 east. North 17, 07, 08 west. And north 53, 51, 15 west. You could do azimuths if you like. I personally prefer the bearings. It also forces you to think about your positive and negative signs with your latitudes and departures, so that's very important. Speaking of lats and deps, latitude is cosine, departure is sine. We've gone through how that's figured out a number of times, so we don't need to take a look at that right now. But to figure out our latitudes and departures, just as a reminder, your latitude is equal to the distance times the cosine of your angle, whether that be bearing or departure, and your departure is the distance times the sine of the angle, whether you decide to use bearing or azimuth. Okay, so based on this, let me run my numbers through, and as I do this, we have 603.1 times cosine of 48 degrees, 8 minutes, 46 seconds. That will be 402.41. And I'll put my signs in later on. 603.1 times sine of 48 degrees, 8 minutes, 46 seconds. And I should remind you, make sure your calculator is in degree mode. That'll be on your final so that you don't forget. 924.1 times cosine, 72, 27, 23. This would be 278.55. 924.1 times sine of 72, 27, 23. 881.12. 488.5 times cosine of 17 degrees, 7 minutes, 8 seconds. We get 466.86, and 488.5 times sine of 17.78, 143.79. Then we have 366.4 times cosine of 53, 51, 15, 216.12. And lastly, 366.4 times sine of 53, 51, 15, 295.87. Sorry, 87. Okay. Let's take a look at these numbers now and see where we're at with summing the latitude and summing the departures. Let's just check that list. 366.4 times cosine 53, 51, 15. 1, 2, and then let's see, 366.4 times sine. It's always good to double check your work. 295.874. Okay, that's it. So I need to look at my sums at this point. Let's move this over. When I sum these, before I sum them, I got to put signs to it. We've said north and east are positive, south and west are negative. So south, negative, west, negative, south, negative, east, positive, north, positive, west, negative, north, positive, west, negative. Okay, let's add them up, see what we got. So I have negative 402.41 minus 278.55 plus 466.86 plus 216.12, 2.02 positive. And then 449.22 plus 881.12. I'm sorry, it's negative. Negative 449.22 plus 881.12 minus 143.79 minus 295.87, negative 7.76. Okay, that's my latitudes and departures. That's what I have. My error for something like that, my error of closure is equal to the square root of the sum of the latitudes squared plus the sum of the departures squared. This is telling me how far off I am in total. So right now, it's going to be quite a bit. 2.02 squared plus a negative 7.76 squared. That's actually too much for a survey. We typically would redo this type of work, redo the survey completely, being this far off. 2.02 squared plus negative 7.76 squared, square root. Wow, I'm off by 8 feet, 802 feet, right? Being off by that far even though we are going by about a half a mile, you're still way too far off. You'd have to redo the survey. This is too much to be adjusting in a real world situation. In college, where nothing's real, we can adjust anything. All right, so let's take a look at our CLATs and CDEPs now. Okay, move over to the side for, actually I'll move up here a little bit for CLATs and CDEPs. The correction in your latitude, we take that as the negative sum of the latitudes times the distance over the perimeter. And the correction of the departure is equal to the negative sum of the departure times the distance of the line over the perimeter. Again, I can't stress this enough. The negative sign is just to reverse the sum of the latitude. So if you get a positive sum, you want a negative correction. If you get a negative sum, you want a positive correction. We're just forcing this to go in the opposite direction to be closed. So in this case, as far as the distance goes, we're looking at this distance for a given line and that perimeter. So we have 603.1 divide 2382.1. And that will be times 2.02. So I'm getting a correction of my latitude of 0.51. Now, these are all positive. This is a positive sum, so all my corrections will be negative. And on my departures, it's negative. All my corrections will be positive. So I can put the signs in right off the bat. Next one, 924.1. Actually, let me do my departures while I'm here. 603.1 divide 2382.1 times 7.76. So let's see, 1.96. Whoops, 1.9964. So 196. Keep your rounding rules in. 924.1 divide 2382.1 is 0.387, so that's 39. Divide 202 times 7.76, 1.49. 488.5 divide 2382.1 times 2.02, 0.41, and 1.59. And lastly, 366.4 divide 2382.1 times 2.02, 0.31, times 7.76 is 1.19. Okay, I don't know if these are right or wrong until I add them up. I have to sum them up. So let's see what I get. Negative 0.51 plus a negative 0.39 plus negative 0.41 and 31, 1.62. Let's see, something's not right. Okay, so I have a mistake in here. I got to go back and check. Let's try the other one. 1.96 plus 1.49 plus 1.59 plus 1.19, 623. All right, so I have a big mistake in here. I got to figure out what I did wrong here. So let me just double check. I think this 924.1 divide 2382.1 times 2.02. Yeah, I thought that might be right. This should be 0.78, and then that would be 3.01. Okay. And that's what you have to do. I'm kind of glad I made that mistake to show you what can happen. Had I know that was where the error was, I took a wild guess. It was the second number I was adding or multiplying. I said, let me just try it. And luckily I hit it. Otherwise, I'd have to go through all of them. Let's try again. 0.51 plus 0.78, 0.41, 0.31, negative 2.01. Okay, we're still not there, but we're close. 1.96 plus 3.01 plus 1.59 plus 1.19, 7.75. Let's see. 603.1 divide 2382.1 times 7.76. 196. Okay. Let's see. 5, 9, and 1. Okay, that's just the numbers the way they are. So I have to adjust a little bit. So we go to the biggest line. Biggest line is 924. So we're going to adjust this one and this one. This has to adjust to be 2.02. So I'm going to make this, do it in red, negative 0.79. And now when I do this, 0.51 plus 0.79 plus 0.41 plus 0.31, I'm at negative 2.02. It's adjusted. And then I'll adjust this one. Now this has to go to 776, or I'm off by 775. So I have to go up one as well. So I'll make this 3.02. And I check it. 1.96 plus 3.02 plus 1.59 plus 1.19, 7.76. Good. Okay, so I've adjusted the corrections. Now I'm going to find my balanced lats and balanced depths. And for that, I just add my correction to my original latitude and then my departure to my correction to my original departure. Again, be careful with your math. Watch what you're writing. Make sure you don't misnumber anything. So 402.41 minus 0.51, or adding a negative, gives me 401.90. 278.55 minus 0.79. 277.76. Negative, negative. Oh, you know what? These are going to be wrong because I didn't put my negative sign in to begin with. Try that one more time. Negative 402.41 minus 0.51. Negative 402.92. And negative 278.55 minus 0.79 is negative 279.34. Positive 466.86 minus 0.41 is 466.45. 216.12 minus 0.31 is 215.81. When I add these up, negative 402.92 minus 279.34 plus 466.45 plus 215.81, 0.01. Make sure I don't have a math mistake in here. Let's see this. 216.12 minus 0.31. Okay, 466.86 minus 0.41. 45. 278.55 negative minus 0.79. 2734. And 402.41 minus 0.51. 402.41 minus 0.51. Why did I put 2? 409. Oh, it's a negative, I'm sorry. Negative 402.41 minus 0.51. Okay, yeah, 402.92. Adding those up, minus 279.34 plus 466.45 and minus 215.81. One more time, negative 402.92 minus 279.334 plus 466.45 plus 215.81, 0. Okay, latitudes balance. A little bit tough, we got through it. Departures. Okay. Back to balanced departures. So the balanced departures, I have 449.22 plus 1.96. 451.18. 881.12 plus 3.02. 884.14. Oh, I did it again. I forgot the negative sign. Negative 449.22 plus 1.96. That's negative 447.26. Negative 143.79 plus 1.59. That's negative 142.20 and negative 295.87 plus 1.19. If you forget the negative sign, it will show up later. 142.2 plus 884.14, 447.26. How'd that happen? 295.87. 295.87 plus 1.19 is 297.06. That's a negative sign. I missed that. Negative 295.87 plus 1.19. Negative 294.68. So negative 447.26 plus 884.14 minus 142.2 minus 294.68. 0. Good. Okay, my balanced latitudes, balanced departures work. Check and check. Once I have balanced latitudes and balanced departures, now I can figure out new distances and new bearings. Now with the distances, this is simply square and square roots. We square the latitude, square the departure, and square root the sum. So we have 402.92 squared plus 447.26 squared equals square root equals 601.99. 279.34 squared plus 884.14 squared equals square root equals 927.22. 466.45 squared plus 142.2 squared equals square root 487.64. 215.81 squared plus 294.68 squared equals square root equals 365.25. Now when I sum these up, hopefully this matches what I had before. 601.99 plus 927.22 plus 487.64 plus 365.25, 2382.10. And that, let's see, I don't remember what I had, 23821, 2382.10. Awesome. Okay, it matches. That's great. So that's another check. Now I'll do my bearing. For my bearing, you know what I'm going to do this time? I'm going to do my direction first. This way it's out of the way. Because we know that north and south are opposites. North and east are positive and south and west are negative. So negative would be south-west. Negative south, positive east. Positive north, negative west. Positive north, negative west. Okay, those are my signs. Let's do the bearing angle. It's the inverse tangent of departure over latitude. So second function tangent, departure. Don't do the signs. 447.26 divide 402.92. Departure over latitude. And we got to convert that to degrees, minutes, and seconds. 7 degrees, 59 minutes. 07.7 be 08 seconds. Second function tangent of departure 884.14 divide 279.34. Second function DMS 72 degrees 27 59 seconds. Second function tangent of 142.2 divide 466.45. 16 degrees, 57 minutes, 15 seconds. 16, 57, 15. And lastly, second function tangent of 294.68 divide 215.81. 53 degrees, 46, and 57.6 becomes 58 seconds. Hold on, did I use the right one? Let me double check that. Second function tangent of departure 294.68 divide 215.81. They missed a parentheses in there. 294.68 divide 215.81. 53, 40, nope, okay, we're good. We're good on that. Okay, that's your compass roll. That's it. We adjusted the bearings and the internal angles. Started with that, got our angles all adjusted, figured out the azimuths and bearings, and then we just went through the whole process of finding our latitudes and departures, finding the corrections of the latitudes and departures, getting new latitudes, new departures, they call them balanced latitudes and balanced departures, getting a new distance and a new bearing. Okay, the only thing left on this that we have is we need to figure out the northings and eastings. So on this one, go back to the original problem. What do we give you as the starting point? We said point D would be 8,000, 8,000. Okay. So we're taking point D as 8,000, 8,000. That's northing and easting. That means we're going to go from D to A, and then AB to point B, then BC to point C, and then CD back to point D. And that's really our last check. So let's do this. Let me copy these over. So it's, whoops, we don't want that. Okay. So I'm going to use my latitude. So dA is, I'll write these in red, negative 402.92, negative 447.26. AB, negative 279.34, 884.14. 466.45, negative 142.20. I move those up, 215.81 and negative 294.68. Move those up just a little bit. Okay. For 2.2. Okay, I think we're good. So now, the reason I like to put them all in order like that is I like to go just down the lines. I start with, let's say my northings. 8,000 minus 402.92 would give me point A of 7,509, 7.08 minus 279.34 is 7317.74 plus 466.45, 7784.19 plus 215.81, 8,000. Awesome, I hit it. That's what I wanted to see. 8,000 minus 447.26 is 7552.74 plus 884.14, 8436.88 minus 142.2, 8294.68 minus 294.68, 8,000. Check. Okay. That is your compass rule with northings and eastings. If you have any questions, shoot me an email. If not, please review this. If you have any questions, like I said, email me, but everything's in here that you need to know. Just have to make sure you can go through the steps piece by piece.